everyone who is here. I know we had a little bit of a late start here. Got a lot going on, but we're doing great. If you're here in the chat, feel free to say hi. We can do some chapter 5. I think chapter 4 is done, is it? Was chapter 4 due last night? Or is chapter 4 still due today? If you're here, it's time to ask questions. We got music now. It doesn't go too loud. Who has questions? I've got answers. It is your time, your office hours. What is coming up due? What is coming up due? Had to write a few mails real quick. So, lot. There we go. A lot of emails. Getting it all done. Woo, funding for... Okay. 2 through 3. I'm going to do it. Getting a proposal in. We might get it, might not. I don't know. It'd be interesting. Talk about the high impact. Let's pull up some MyPearson. No one's here? Oh no, where is everybody? Puppet Shark, you here? Puppet Shark, you here? Yeah. Puppet Shark. Uh-oh. Wrong password. Oh man, it's such a busy day. I got home at like 7:30 last night. Had a little bit of time, made some dinner, went to bed. It was fast. I was falling asleep last night. A few nights ago, I think it was Saturday night, I just fell asleep on the couch. Went upstairs, was watching a YouTube video, and I was just like, my wife came in to say goodnight. I'm just talking to the void right now, talking to myself. And she's like, I came upstairs to say goodnight, and you're just passed out. And I was like, oh, you could have been like, go to bed, and falling asleep. Why are you so tired? But it's due today. Quiz 4. Should I send out announcements? Let's send out an announcement. Let's get some people in here. I'm gonna send a reminder. Say, hey, join in here. If you're doing quiz 4. Today 11th. Today's the 11th. Today's the 11th. Oh, man. Say you want to help on. Want some help on quiz 4? Okay. Need help on quiz 4. Need help on quiz 4? Click here and just let me know which one you're stuck on. Okay, all you have to do is join the stream and just say, Brian, work this question, and we will show how to solve that question. So that's that. Need help on quiz 4? Okay, announcement. Need help. Might do the homework. Okay. We're going to do the homework in the background while we're waiting some people. Chapter 4, homework. Probably everyone did it. It's that easy, right? Everyone's like, chapter 4 is easy. Okay. Let's do some chapter 4 homework. Here we go. Chapter 4 homework. Office hours video. Chapter 4 homework. Getting the stream up. Okay. It's bigger. Let's see it now. Stat 201. Chapter. MyPearson. Chapter 4 homework. Okay. The first question. What do we got going on with the first question right here? This is the Research and Initiative Technology Administration. They got a lot going on right there with that. Was that my Alexa talking to me? That was like something's going on at home. And with this, they've collected some data. Let's look at that data. What we got? We got two different distributions. Two very different distributions right here. They're not so very different. That's the normal curve. You can see that. And when we take a look at these two differing distributions, what do we see? Well, they both have what skew. Once again, don't read their questions. Think about your own questions. Think about your own data, how it goes. You got right here, boop, and you got that. So you got little Monster Man. He's all looking all crazy. This guy's all happy too. There you go, that Monster Man. They got some left skew, right to the high, left to the low, whatever way the Monster Man's tail goes. If you know how to do skew, you will always get this right because that's the low side of the data. When we say low, we mean the low numbers. So right to the high, left to the low, whatever way the Monster Man's tail goes. You'll never forget. And with this right here, we are probably going to compare, we should compare the medians for measure of center. So it's important to note these are measures of center right here. So these are measures of center. And then these are measures of spread, respectively. Now you're only going to select one out of these groups. Because it is skewed, we would compare medians. This one has a higher median compared to this one over here. And then for measures of spread, we should compare the IQRs. And also this one, the domestic load, has a bigger IQR, which is probably somewhere in here. It'd have to be around the median. And this one's going to be a little bit smaller. Not too much smaller, just one smaller. So the proper measures of center and spread respectively are median and IQR due to the left skew nature of the data. So what do we see? Both distributions are skewed to the left. We've narrowed it down. The domestic load varies a bit more, and we saw that because domestic has a bigger IQR. So the domestic load varying more has a bigger IQR, specifically right there. The domestic load has a more variation in it. Double check your answer. Make sure you got it right. Left skew, domestic load has a bigger variation. Next, we go here to the electric car question, and that's the electric car right there. This question is kind of getting into what do outliers impact, and they can impact a lot. So once again, whenever you look at data, there's a lot of chapter 2. I know it's chapter 4, but chapter 2 is kind of coming into play right here. So you always want to look at the shape of data first. And it'd be much better if we had a histogram. The histogram would kind of look like this right here, and then there'd be one boop all the way over there. The histogram would be very, very right skewed. And actually, it's kind of symmetric at the bottom. I stand corrected. It's a little bit more symmetric. So it might look something more like this. And then you got this one outlier there, and then you got an outlier over here. There might be more data. But looking at the distances, it might be even more unimodal. It's hard to tell. Because this is more built up. There's more data right here. Because this, I'm going to highlight 25%. This is 25% of the data. That's 25% of the data. This is 25% of the data. And this is 25%. So all of those blue regions, which you can see it's more stretched out on the high side, the outliers are definitely making some right skew to the data. The histogram, if we had it, would be easier to see. Box plots do not show shape as well as histograms. They show the 5-number summary. The 5-number summary being included right here are going to be the values. I like a light purple. Is going to be the min, the Q1, the median, the Q3, the max, which are respectively the min, the Q1, the median, the Q3, and the max. The top of the whisker is the highest point that is not an outlier. That is not Q3 or the max. A lot of people get that wrong on the test. So I've marked the 5-number summary on the box plot, and you can see because Q3 and the max is the 75th percentile all the way to the 100th percentile, and thus 25% of the data would be contained between the Q3 and the maximum value. These are the percentiles. If you think about the min is the lowest, the 0th percentile, the Q1, 1/4, 25%, and median 50th percentile. All the while being those marks right there on the curve. So with this, what does it ask us? We're removing the electric car effect standard deviation. Well, what is standard deviation? We just said it a second ago. It's a metric of spread. So will the data be less spread out? The answer is yes. It won't affect IQR, which is the next question. IQR only looks at the spread of the middle 50%, which is right in there. This is the IQR. It's the box of the box plot. The literal box of the box plot is the IQR. The box of it, as in from here to here, is the IQR. The range, IQR, interquartile range of the middle 50%. Found by the formula, you know it by now, I bet. Q3 minus Q1, but it doesn't hurt to practice. So the IQR here is 5. Mathematically, 25 minus 20. So the reason that outliers don't impact that is because removing this point would not impact the range of the middle 50%. It's still the same distance between 20 to 25. But what it would impact is the formula for the standard deviation. That's because the formula for the standard deviation is square root of the observation of the y times the mean of y squaring those differences. And if you notice right here, the mean is used. And so we're calculating a distance from the mean. And with calculating the distance from the mean, this point is very far from the mean. And since it's so far from the mean, it inflates how things are standardly deviating from the mean. So whenever you hear standard deviation, I want you to think, how far do things standardly deviate from the mean? The mean being a value somewhere down here. If the mean is a value, it's probably right around, and it's being inflated, so we'll raise it up a little bit to the outliers. And would this be a bigger deviation from the mean? Would it increase deviations from the mean? Yeah, things are further out from the mean with that point. So removing that point would decrease standard deviation because it's less variation in the data. So it'd be much lower. The standard deviation calculates the sum of the squaring the values. And let's see, they're trying to trick us. The squared differences. And if you're wondering why it's the sum of the squared differences, mathematically on the far left side of the screen, the sum of the squared differences is seen. I'll highlight this in highlighter. It's a good thing to highlight things in. The sum of the squared differences is right here, summing the squared differences. So that is the mathematics behind it, summing of the squared differences. And that's what they say right there. How will removing electric cars affect the IQR? It won't. It basically nothing would happen. It changes positions, but virtually nothing would happen with it. So good question. 2 down. Homework's almost done. If you're here watching this, you get homework done and see some answers and learn some lecture. So next we have the load factors from 2020 to 2002. 2002, that's what we used to call it back in the day, to 2019. You don't gotta say 20 at the start of those. And we have some what graphic. Now, please take a screenshot of this if you don't have it. If you're watching the video in the future, I'm kind of making this for future people right here. But this right here is all the graphics. And you notice if we have a categorical X and quantitative Y, cat X, if you're going across this bottom, it's categorical X, quant Y, side-by-side box plots. So this is a side-by-side box plots, which is the visualization of a categorical X, like what month is it, categories, and international load factor, which is a quantity of how much is the international load factor. And then we take a screenshot. We make it nice and big right here. And then we'll scroll down. We go right here. So can you do the question about Fran and Iris? Yeah, let's do it. We'll put that on here. Thank you for being here, Carla. That's a good one. That's going to be on the quiz. We'll do that quiz question coming up here. We'll finish the homework and do that quiz question right next. We've got some outliers in here. We've got a change throughout the medians. So median follows kind of a sine wave pattern. So the medians have a trend going through them. We might see a small bit of change to the IQRs. IQRs are mostly stable. Ranges have big range differences. So IQRs are basically the same. Median increase in the summer months. Excuse me. I don't know when winter is. We found that out yesterday. Ranges are differing due to outliers. There's some big range changes due to outliers. So I do see some differences in ranges. There's some months with some rather large ranges. I do see some outliers. And let's see what they ask us. You just got to know what you're looking at. Hey, Darius, good to see you there. Yeah, we've already got one question. We've got the Iris and Fran about to play some football, I think. So load factors are generally higher during the summer months, and the load factors are more variable during those winter, spring months. I think we should be fine because we saw that summer was the highest, so that's where we kind of figured it out. And we see right here these summer months from, that'd be August, June, July right there. So that coincides with just this answer was needed, and we got it. 2 more. Which of the following is true about a box plot? 2 more, and then we got some quiz questions. So Darius, drop the quiz questions. We're going to do quiz questions right after this. We already got Fran and Iris coming up next. So what is true about a box plot? We should know all of these. Not like they're all right. Maybe they are. The values which are displayed by a dot or an asterisk are an outlier. Facts. When you make the box, you go up 1.5. Now the whisker doesn't need to go all the way. There's a fence that we don't see that is 1.5 IQRs above Q3. And there can be a lower fence. You could have a lower fence down here. You don't usually draw these. They're just graphical techniques. But this would be 1.5 IQRs below Q1. It's 1.5 IQRs, the distance. We don't have you draw too many by hand, but you would literally draw it out and draw the 1.5 IQRs above or below Q1 or Q3 respectively. There's the median right there. And if things fall outside of this, they are outliers. We put a dot for things that are barely outside. And if you go 3 IQRs, then they get an asterisk. They get a nice big asterisk to mean like extreme. Not everyone does that, but this is true. Things that are outliers that are more than 1.5 IQRs above Q3 or 1.5 IQRs below Q1 will get a dot or an asterisk respectively. Good job. Let's do that one. We got that second. The center of a box plot is a box that shows the middle half of the data. You bet. The center of the box being the box right here showing the middle half is Q3 through Q1 respectively. That is the middle half, the IQR. The center represents the median. You bet. That's the median right there. You already labeled it. Box plots are great for comparing more than 2 distributions, and we just did that in the last question. You can do side-by-side box plots, as we saw. So yes, side-by-side box plots right there, great for comparing multiple distributions. So these are all accurate, and you should be able to draw them and understand them. And I know you can just see the answer, but they're all true. Last one, and then we got Fran and Iris, and we got some box plots showing fuel economy. Hang out, Darius and Carla. We're going to do those next. Answer some questions, too. I love it. Let's start you some points for being here. 500 points for being here. Okay, the research initiative is looking at some load factors again. Man, they love those international load factors. This one's a bit tricky. It almost tricked me yesterday, but it didn't. And, oh, this is a different one. We're looking at the yearly trend over time by year. And years being treated as a group right here. So we have a categorical X, and we have a quantitative Y. And you can see that the median is increasing. So you always want to think, what do you see with this data first? Is the median is increasing over time. It is leveling off. So if we did a time series on this, we would see the trend where it goes up and levels off. We do have one outlier that is unusual for that year. It might not be unusual for the full data set. That's kind of how the other one goes. But we also see some decrease in variation. The range of the data set gets smaller. Also, IQRs get smaller. There's a decrease to the range and variation seen in both the IQR and the range of the data in the middle 50%. So I should mark that too. The IQR, if we mark that here in blue, is bigger to start, and it gets smaller at the end. That's way too much blue. Let's go with orange. Okay, there's the IQR, and the IQR is getting a bit smaller. Okay, so we see a more stable, as in less variation, higher median. Let's see what they ask. Okay, they ask, do you think the data for months affected by extraordinary weather events should be set aside in overall analysis of load factors? That weird point right there. So air travel after extraordinary weather events are not typical. In order to analyze monthly patterns, it might be best to set these days aside. Sure, never ignore outliers. That's a long way to say don't ignore outliers. A lot of things to show us to say don't just ignore outliers. That was a very, very don't ignore outliers. Give them special. I'll give you your special attention outlier. Okay, who's ready for the questions? We got Fran and Iris, and we've got the box plots showing fuel economy. So let's go grab those. That is the full homework done in 13 minutes with explanations. The full homework, 13 minutes. It's not 201, MyPearson Chapter 4 quiz. Fran and Iris. Okay, we're going to go find that Fran and Iris question. And with this, if we do a bunch of these today, we'll have done like everything. Remember, join into these anytime you want. If you're watching this in the future, just hop in one of these live and just drop a question. Like, Brian, how do I solve this one? We'll solve it. If I get it wrong, it's okay. Where's the upper fence? 6. 19. Let's see, Fran and Iris. Fran and Iris. That's a good one. Where'd they go? Oh, here is... I think this is yours, right? No, that might be a different one. We need the subcompact cars. Am I missing it? Am I missing the Fran and Iris one? Is it chapter 4? Is it chapter 4, Carla? Am I missing it? Am I going crazy? I feel like I've gone mad. It's chapter 4. Oh, Holly and Iris. Here's Holly and Iris. Yeah, they changed the name. Let me re-timestamp this real quick. Yeah, thank you so much. Let me throw some points. Okay. And we adjusted the music. The music should be good now. Okay. We're adjusting the timestamp. Holly and Iris, Fran and Iris. Try to see. Okay, there we go. Let's do it. Okay. How are these distributions the same? How are they different? Don't read their questions. Think about mine. How are these distributions the same? How are they different? the end of the basketball game. We can pick between Holly and Iris. How are these distributions the same? How are they different? Don't worry about their questions. Just think about mine. How are these distributions the same? How are they different? Any similarities, any differences? The same median, I like that. So they get typically the same amount. They get typically the same amount. But you notice they have a much differing spread. Now, if it's the end of the game and we need a lot of points, we're down. Coach says, we're down by 25. Who are we putting in? You're saying what? We're down by 25. Who are we putting in? We're down by 25. Who are we putting in? We're down by 25. Who are we putting in? We're down by 25. I put in Holly. Yeah. I mean, the only one who's ever scored that many points would be Holly, right? So we need 25 points. We're putting in Holly. Coach says, we are down by only 10. We need our player who can, I don't know how they're going to get this many at the end of the game. Coach says, we're down by only 10. Who are we putting in? We're down by only 10. Has Holly ever gotten less than 10 points? Now we're down by only 10. Now I'd probably put in Iris because Iris is more consistent. Iris does not have as high of numbers. Does that make sense? Kind of like the choice of which player to put in, they both have the same average, but they have different spreads to their data. The Holly has a higher range and a higher IQR, probably bigger standard deviation too, but that's not really best shown in a box plot. So that's kind of the theme of this question is that you can have the same average or median box plots and have differences. Both girls have the same median. They do not have the same IQR. Both girls have the same median, but Holly has a larger IQR. So the answer to who put in the game really depends on what we need at that moment. That's the full question. Does that make sense, Carla? Like, you'd expect them to both do about the same, but Holly has a higher potential, but also a lower, like, she could do way worse. Holly has more variation in her data, where Iris has less variation. So really good. Yeah, good question. The Boxplot shows the fuel economy. Don't worry, that's a tough one sometimes. It's like, well, what are they getting at here? What are they getting at? You got to think, Coach, put me in the game. Okay, Darius, let's do another. We got 31, 23. There you go. Okay, so this one is the Boxplot shows. Drop some more questions in the chat. We don't have that many right now. The Boxplot shows fuel economies. We don't have any more questions. Is that it? Wait, is that it? No, that's not it. Fuel economy. I wish there was a search for question. That'd be amazing. They don't expect people to do what I do, though. Teacher's just like, here, we'll just solve them all. I could do that. Solve them all in order. So it's like the last one. Is this it right here? We got it? Is this it, Darius right here? Sorry, Darius. Is this it, Darius? Let me know if I've got the wrong one. Yep. Okay, let's do it. Okay, so for this one right here, this is dealing with electric cars. And this is the electric car in the data set. So when you think about this electric car, it's a huge what in the data set. That electric car right there is a huge what. It's a ridiculous what. It's a ridiculous what? It's a ridiculous what? Well, it's way out here. That's a hint. It's way out here from the rest of the data. It's way out here. It's way out there. Outlier, you got it, Darius. Points in the chat. You're right. It's a huge outlier. It's very unusual. And when you have outliers, what should you use? Imagine I like to do my example where I say you work for a company and they say we pay $1 million to our coworkers on average. $1 million. Like, oh my gosh, this company pays $1 million. And they find out there's 10 coworkers. So there's 10 people at the company, and the boss is getting $10 million. And everyone else is getting zero. And you're like, well, this was a bad idea. So the average for this company would be $1 million. We had 10 coworkers, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the median would be 0. The median would be 0. So when we have outliers, here's a question. What is the proper measure of spread if there's outliers? If there are outliers, the proper measure of spread, you got a lot of answers on the screen. If there's outliers, what is the proper measure of spread? If there's outliers, what is the proper measure of spread? If there's outliers, what is the proper measure of spread? Good guess, Darius. The median is the proper measure of center, and the IQR is the proper measure of spread. Center and spread. I have these in order of center spread. So the proper measure of spread would be the IQR. Good guess. Let me throw you a few more points. So make sure you have these written down. When data is skewed or with outliers, great job, Adeline, right there. When data is skewed or has outliers, median for center, IQR for spread. And if data is more normally distributed, center and spread are mean and standard deviation respectively. That's CNS right there above it. Yeah, exactly. So why do we use the IQR? Well, think about this. If the IQR is from here to here, does anyone know what the IQR for this data is? What is the IQR for this data? What is the IQR for that data over here? It'd be from 0 to 0. So what is the IQR? What is the range in the middle 50%? It'd be from 0 to 0. So think, from 0 to 0 is the answer. So the answer is what? What would be the IQR? It'd be 0. Great job, Darius. So do outliers impact the IQR? Yes or no? Do outliers impact the IQR? Yes or no? Very clearly, do outliers impact the IQR? Like, the boss gives himself a raise, and the boss is like, now I make 100 million. And we got the boss's salary down. Like, no, you make 100,000. Do outliers impact the IQR? Yes or no? Huge thing to know. Don't worry if you get it wrong. Do outliers impact the IQR? Yes or no? Write this note down if you don't have it. Once I say it. No, they do not. You're right. No, the answer is you are correct. No, they do not. Outliers would impact the mean and standard deviation. They will greatly inflate or deflate depending on which direction they go. Outliers that will increase standard deviation are far away from the mean. Outliers that increase the mean are above the mean. Outliers that decrease the mean are below the mean. Standard deviation can only go as low as 0. So outliers don't decrease standard deviation ever. They just spread out data more because they're further away from the central part of the data. So what would removing this point right here do to the standard deviation? It would reduce spread. Yeah, Carl, let's do that one next. It would reduce spread. So since it would reduce the spread and standard deviation is a metric of spread, the standard deviation would be much lower. And it's actually calculated by summing the squared values. They're getting a little technical on this. I'll write the equation again. The formula for standard deviation is standard deviation equals to the square root of the sum of the squared differences between an observation and the mean. Square those differences. You don't have to write this formula. It's just showing you that, and then n minus 1 for sample. So it's the sum of the squared differences between an observation and its mean. And that's what they literally state right here in the problem. Standard deviation is calculated by summing the squared differences of the data values and the means. And you can see that here visually with what I've had it highlighted. Summing the squared differences between an observation and its mean. And they could have said n divided by n1 and n minus 1 and then square rooting it to bring it back to use the problem so you don't get variance. We don't need to know that. And next, does it impact the IQR, A, B, C, or D? So with what we've learned, just read the start. Will it impact the IQR? If we remove that point, will it impact the IQR? A, B, C, or D? This is a review question for you right now. A, B, C, or D? And I'm going to get Carla's question going. We don't have any more questions, so drop more questions. Will it impact the IQR? Yes or no? And in what way, if so? What do you think? A, B, C, or D? Don't worry if you get it wrong. It is B. It will not change the IQR because the IQR is not impacted by outliers. Great job, Alan, right there. I'll show you some points. Okay, drop more questions. Good practice. Here we go with the student. We might have done it. It's not the one, right? Student in intro statistics class. Here we go. Okay. The upper fence. Okay, so let's take a look right here. The upper fence is a graphical technique which is used to tell us where outliers begin and end. I'm going to make a fake data set right here, and I want you to tell me where the upper fence is. So here's a data set of push-ups. I'm doing 5 push-ups a day. 5 push-ups a day keeps the doctor away. There's my 5 push-ups. Someone 10, 5, 10, 5, 15. Sure, why not? Oh my gosh. Sure, why not? That's too big. We'll go with the scale. Okay, I hope the IQR is 5. And distribution. Here we go. Yep. What's the IQR? What is the IQR and how is it calculated if you want? Who sees the IQR here and how is it calculated? You can actually visually see the IQR. The median is actually on top of the IQR. Yeah, I'll do some Chapter 5 quiz. Let's do that. Adeline, drop a Chapter 5 quiz. We'll start doing that next. We've done a lot of Chapter 4. What is the IQR? Does anyone know it? Figure it out. I kind of said it a moment ago. And tell me mathematically what the IQR is. Like, how do you find it mathematically? Q3 minus Q1. So what is it, Darius? You're on there. You got it. Darius, good work. So what is it mathematically? Ooh. See if Carlton wants to say no. We're streaming. Oh, right now? 12:15. Yes. If not, it's okay. I just want to make sure you're still good. It's on my schedule, isn't it? Let me see. I can't believe it. Man. Google Calendar. 1 second. I think I put it on my... Oh, how did I not see it? You're right. Okay. Yeah, and it's till like 1, right? Or... Yeah. Okay. 1:30? Okay. Cool. It's okay if not. I probably shouldn't. Okay. It's okay if not? Yeah, it's fine. I'm going to stay here and help. I'm sorry. That's okay. All right. That's all good. No worries. All right. Thank you, Carlton. Oh, man. Okay. I put a thing on my calendar and I forgot. It's been so busy. But I'm going to stay here and help because we're going to do some Chapter 5. I turned down a free lunch. Free lunch. Oh, man. It's been a good free lunch. We're going to stay here and help. I know, right, Darius? I felt bad, and I was like, I forgot that was on my calendar. It's literally on my calendar. And then there's ice cream today. There's literally ice cream on my calendar. I can't go get ice cream. There's ice cream. Look at that. There's ice cream. Where's all that right there? I'd have to shift a lot around. Yeah. I think we're good. Yeah. Okay. So, Carla, you are right. It is 5. From 10 to 5 is 5. So here's the question. Where is the... I know, right? It's at the creamery, so it's far away. I don't even know if I signed up or I can't remember. It's at the creamery. It's far away. Where is the upper fence? Does anyone know where the upper fence is? So the formula, I'll write it out for you right here. We're going to practice. Don't worry. I'm going to get home tonight, and I'm going to relax. I'm going to play some Lies of P. Good video game. So the upper fence, to find it, and this is what we're trying to do in this question, is the formula Q3 plus 1.5 IQR. So we have to take the IQR equal to 5 and plug in Q3. So where is the upper fence? Try to solve it right now and tell me where is the upper fence. Visually, it's right there. So where is it? Where is the upper fence? I might go say hey real quick after them. It's at 17.5. 17.5. And with 17.5, it's because we simply add right here. I'm going to go say hey to them right after this, and we're going to come back and do more. We take 10 plus 1.5 times 5, and we can confirm this. That'd be 17.5 by going to the data and watch this. If I change one of these points and go to automatic recalc, so let's go to automatic recalc, redo, no. And if we change automatic recalc here and we change this 25, let's say, we change this 25 to 18, notice it is an outlier. If we change it to 17, it's not an outlier. 17.5, it's not an outlier. 17.51, it is an outlier. So it's right at 17.5 is where the fence is. Now you don't see it. So for this question, I'll be right back. I'm going to go say hey to them and apologize. Would this be an outlier? The upper fence is here. So is her maximum outside the upper fence? Yes or no? Is the maximum in her data set outside the upper fence? Yes or no? Is the maximum outside the upper fence? Yes or no? Yes. So it's definitely an outlier. Now, what I want you to do, I'm going to be back in like 3 to 4 minutes. I want you to drop so many chapter 4 and chapter 5 questions. We're going to come back and we're going to do a bunch of them. So we're going to take a quick 4-minute break, but drop those chapter 5 and chapter 4 questions. I'll be right back here in a moment. Put some chapter 5 and chapter 4. Be right back. We are back. Man, that ice cream sounds really good. We got a lot of help we need, though. We're going to help out. We're going to win. Describe what the Boxplots tells you about the relationship of... Is that chapter 4? Let's do that one. A little more chapter 4? Chapter 5. Okay. Let's do this. Really huge thank you. Students come first. And I want to say that. Like, free lunch is nice, but students come first. Describe what the Boxplot tells us. So I grabbed it. I actually took a little bit more of a break, so I feel even worse. I'm like, I can't do it because got a break. Here we'll do Darius's 2 questions, then Adeline, we're gonna do your 2 questions next. We got just enough time to do it. Then we're doing in-person office hours. So stat 201. I did stat wrong number right there. Okay, Darius, here is the question, and let's explain it. And don't worry about getting anything wrong. We're here to practice. So describe. You're welcome, Darius. I appreciate people being here. If no one had shown up and they'd be like, bro, let's go to lunch, I'd be like, bye, everybody. Let's do this. What do we notice right here? Random news popping up. That's what we notice. Is we have Boxplots, and we see that there's not a lot of 5-cylinder cars. 5-cylinder cars are just not a thing as far as I knew. And you really see this decreasing trend along the lines where it is decreasing as it goes down, and the cars generally have lower fuel efficiency. There is a bit of an outlier over here, and there's less variation. There's more variation down here. So we see a trend in the analysis where more cylinders equals less fuel efficiency. I didn't know that. I thought more cylinders would be better. I guess all those piston firings is not a good thing. So as the cylinders increase, fuel economy tends to decrease. That eliminates that one as a right answer. And it also becomes less variable because there's a tighter distribution. 5 is kind of a one-off outlier weirdness, but you should almost remove that from the analysis because it's just one observation. And so you do see a large amount of variation, a medium amount of variation, and a small, specifically highlighted by the width of this or the range of the data, that it is generally getting a little bit smaller. 5 is just one of those weird ones. I wish they didn't include it. It would make the answer a little bit more obvious. So good question, and we'll do the next one right here. Study reports load factors. Okay. We are at the 48:33. Stat 201, MyPearson Chapter 4 quiz. A study reports load factors. Tell me if I get the right one here, Darius. Standard reports load factors. Let's go. We did it yesterday. Chapter 5. Chapter 5 is my favorite. I'm not even kidding. You might hate Chapter 5, but I love Chapter 5. Darius, if I missed the number, please tell me. If you see me like, Brian, wait, number 12. We did Travelers yesterday, so if you're looking for Travelers, check out yesterday. We didn't do Frozen Pizza, but it's basically the same. Here we go, study reports, load factors. And what do we have going on right here? It's the month and the yearly data. So what we have is data can look weird by the way you group it. Is it weird that my nephew is 5 feet tall, yes or no? Is it weird that my nephew's 5 feet tall? Is it weird that he's 5 feet tall? By weird, we mean unusual. We're not saying bad. It's just weird. Is it unusual? Is it odd? Depends on his age. He's 5. So what? It's a 5 foot tall 5-year-old? No, not really. And it doesn't matter if you're short. Doesn't matter if you're tall. All data needs context. And by weird, we mean far away from the mean or median, unusual. Like LeBron is very weird. Shaq is very weird. Who's the guy? Larry Bird's very weird. What's his name? Dennis Rodman is weird. He's also very tall. Sorry, Dennis. Dennis Rodman would laugh. He'd say, yeah, I'm Dennis Rodman. He's my favorite basketball player as a kid. So we mean unusual, and we need the context for it on what's going on with the data. And if you look at the data in a full totality of it, certain things stick out. But things were not as unusual if you go within the months. Like this right here is actually around 80, so it would be right here. It's actually very much towards the median of the full data set. So things that may stick out in the full data set may not seem unusual when plotted by the months. Does that make sense? In the months, that's the year rather. In the year that they occurred, they don't seem that weird. But within the full data set, they might seem weird. So because we got all these points down here, which mainly come from the start of the series, which the company had an increase on domestic load factors. So things that may, let's see right here, context all depends. It's all context, right? Data values that may seem ordinary when placed against the yearly data may stand out when compared for the entire data set. So, and that's what we see is data values that may seem ordinary up here. And we should highlight just this right here. These seem ordinary. Well, sure. Then we'll remove this. These all seem ordinary, especially the data I highlighted in purple right there, pink, purple, whatever. And then down at the bottom, they don't seem ordinary. They seem like outliers. So data may seem odd if you have, yeah. Okay. Let's do some chapter 5. Okay. Chapter 5. Hair's getting really long. Really long for short hair, Brian. I should go get my haircut. Maybe Friday. Friday would be a good haircut day. Okay. A Forester measured the trees. I like this one. Just look at the trees. Okay. How are you doing, Darius and Adeline right there? Are you ready for some chapter 5, the chapter that people hate? I keep saying that. And my favorite chapter, chapter 5. And ready? Oh, Darius, that is awesome. Let's show you some points. So chapter 5, and this is, woohoo, Forester measured 36 trees. And with this one, the Forester question, have your drawing ready. So in our class, that one's the same, a drawing question. Here it is, the drawing question. Now they give you a drawing, but take a moment right here and draw out the normal curve. This is what we did during our class today. We drew out the normal curve, and we wrote all these numbers on it to help us out, and this is a huge help. It covers the 68, 95, 99.7 rule, which is going to tell us the percent of data contained within so many standard deviations plus or minus. I'm using the eraser native on the pen. And so you can see here, we didn't put the context of the data right now. We're going to erase this up here, and we can write the context of the data down below, and we can keep this curve for use. So have this curve ready, and what they give us here is a mean of 10.2 and a standard deviation of 4.4. Now you can make your life easier if you call it 10 and 4. That's just a little bit easier. So we go normally distributed with a mean of 10 and a standard deviation of 4. I'm just doing this to make life easier because now I go 10, 14, 18, 22, and then you go down 6, 4, and negative 2. Is that what they got going on right here? They're going negative? You can't have a negative tree. Well, apparently, it's one of the first times I've ever seen that in this question. Yeah, look at that. So we need to have the 68, 95, 99.7. Does that make sense right there, Adeline? That we do have the 10.2, the 4, and it's going up by 4 basically each time, and then 68, 95, 99.7. The empirical numbers are shown, and try drawing it out for yourself if you have this from class. It'll really help. You just put the numbers below it, and you can see the z-scores above it right there. So that's going to be a huge help for doing this question. I'm going to look for basically these numbers. The middle 95% of trees, all we do is look at the middle 95 between 1.4 to 19 right there. So the numbers are given on the middle 95, 1.4 to 19. So we go right here and do 1.4 to 19. What percent of trees should have diameters below 1.4? And we've already drawn it out, but I think you can figure it out looking at this picture. If 95% is inside, what is total? I want the total first. What is total outside of 95? I want total first. What is total outside? Total outside of 95. Total. What is total outside? What is the total outside of 95? If 95% is inside, what is total outside of it? Remaining outside. You just have to think 95% of the pizza in my hands, what's outside of it? Like a remainder out of 100. So you subtract from 100. If you think how to do it, subtract from 100. What is the remainder? Out of 100 is what? And don't worry if you're wrong, just take a guess. What will be the remainder out of 100? It is 5, Darius, you got it. So what do you think each of these is worth if it's total 5? If it's total 5, and that's symmetric, what are each of those worth? Darius, great job. What are each of those worth if it's total 5? What are each of those worth? Because it's symmetric. Due to the symmetry, each of these is worth it's symmetric, adds up to 5. And they're both worth the same, and it adds up to 5, so because total, that's 5. There we go. And I like to do the riding the rails trick, where you're like, I'm going to ride this right here. Be like, whee! And you have to add up to 100 if you do that. Do you ride it, Darius? Yep. So does that make sense? Like, if you were to ride this and go across this right here, across the full distribution, which means you would shade in the full distribution, you'd have to be shading in 100% of the curve, and you've done it properly. So below that point, I think it said below. Be careful, it might say above or below. It does say should have below, and that's 2.5. Next, we see what percent are between 19 and 23.4. So between 19 and 23.4, make sure you're using the correct graphic. 19 and 23.4 are this little sliver over here. So there's a few ways to get this. We can use the numbers they gave. So 19 and 23.4. How much data am I shading in right now? Tell me how much data am I shading in total? Just figure out the number. How much data have I shaded in? I'm going to make it kind of clear by going right up to those. How much data am I shading in? I'm trying to make it clear right now. That's how much data? 95. And then how much am I shading in if I were to go out to here? Like if I were to go out to there, I've shaded in how much? Because what we want is we want the answer from here. We want this blue area right here. So that's 99.7, and we need to subtract out the inner 95 on it. The inner 95 is this, and then you'd have to go total through it, just to be clear. I am talking if you were to go total through it. So that's the 99.7. Does that make sense? Just visually speaking, is like the 99.7 is the total thing, and then we are going to subtract out the 95. So that leaves 4.7, but 4.7 across both areas. So what's the answer? So the total is 4.7. Ice cream! Not going. The total is 4.7. It's at the creamery. It's far away and it's raining. So what is one of those areas? And in class today, we kind of gave it away because you can see the answer right down there. And you can confirm your answer. What's the answer going to be? The answer was just shown. And these are different each time, so you have to solve each one. 2.35, Darius on fire right there. You got it. Like in NBA Jams. He's on fire! I'm sorry, coworkers. I'm loud. What percent of trees should have over 14.6? 14.6 is right here. You know, it's a classic game. Sometimes I pull some 90s quotes or 80s quotes out on my wife, and she's like, I don't remember that. I say, I remember it. 14.6, does anyone have an answer for this one? What is above 14.6? The area is right here. Try drawing it. And 14.6 has a z-score of 1, which we would have to take this and go outside of it. So there's 32% total outside. So what is one of these worth? I kind of did a bit of the work for you here. What is one of those worth? If there is, just think you have to be like, does this make sense when I say the number? You could also understand that this is 34 and the remainder has to add up to 50. Like if you were to add up these numbers, this plus whatever this is has to be 50. This is 34 because it's half of 68. If you cut 68 in half right there, you get that. So what would the amount be? And then you have to be like, does this make sense? Do these numbers add up? What is the value of the amount of trees above 14.6? And make sure it says above. If it was below, it would be 84%. So what is the amount of area right there? And you can see it's 16. Darius, I said you got it. Yep, and look at the graphic we made today in class. Once again, the graphic is a huge help. If you have the graphic, you can literally plot right there if you know it's a z-score of 1, and you can see the answer of 16 right there. So the graphic is a huge help for these problems. That's why we worked on making that today in class, and you can get these right. Now, if you've done these questions a lot, which I have, I don't know if it'll show a different version if I redo it. Will it? Oh, it does. It does. So I've done these questions a lot, 95% within plus or minus 2 standard deviations. It looks like 68, 95, 99.7. That's a, there we go. That looks correct. No. We got to go down. 68, 95 is this one. And then within plus or minus 2 standard deviations is 1.7 to 18.5, as long as it's the right first graphic. This is below 1.7. That's a z-score of 2. That's 2.5, negative 2 rather. 14.3 to 18.5. That's 34. That's 13.5. 13.5 between the first and second standard deviation. Over 22.7. That's going to be 0.15. Very small, half of 0.3. Yes. So if you've done these problems a lot, you can get these very quickly. If you've done these problems a lot, it's just something you kind of know the 68, 95, 99.7 rule. Does that make sense? Adeline right there. How'd you do on this? I know I did that. The graphic is like interchangeable. Yeah, it is. It's you get it down and then you just like, you can solve the empirical rule very quickly, especially when you practice it. It's really good. It's very useful because the normal model is a very common distribution of data. So we're going to do Adeline's next question right here. Thank you, Adeline, for working so far ahead. Already doing chapter 5. I love it. So let's do the next one right here. The next one was environmental EPA. And then we got one more after this. Environmental EPA. Let's go check it out. Okay. Environmental EPA. There's the Rivet one. Rivet one's classic. It gets a little weird at the end. I don't know. The test one. I hope it's not the last one. That one's a little annoying. That one, I think it's that one. It's like a very long question. Just have you find z-scores. Here we go. Same sort of question. Let me grab the last one. The mean weight. I love this one. Okay, the cattle ones are good. So we got the last question of the day, and then some in-person office hours. So this one with the EPA question. If you take a look, they first want us to graph it. 68, 95, 99.7. The mean of the data is correct for all of these, the standard deviation being 6.22. This one is too small because we have to go up by 6.22. This one is too large. This one is 10. This one is just right. It should go up by 6.22 each time. So you just add 6.22, 6.22, 6.22. Just make sure the numbers on the bottom start with the mean and up by 6.22, which is the standard deviation. You go up and down 3. There are things outside of that, but we won't use those right now. So when it says the middle 95, that's plus or minus how many standard deviations? I'll put the answer in here, but the middle 95 is always plus or minus, and look at what order it is in the numbers. It's always plus or minus how many standard deviations for the middle 95. You can look at the numbers there and find plus or minus this many standard deviations. The middle 95% of the data is contained within plus or minus how many standard deviations? The middle 95 is within plus or minus how many standard deviations? You can see it on our drawing. The middle 95 is always contained within plus or minus how many standard deviations of the data. So you go to the middle 95, within plus or minus how many standard deviations? 2, plus or minus 2 standard deviations. And so now we say, what percent of autos should get more than 31.04? What is the z-score of 31.04? You can see it visually so easily. What is the z-score of 30? It's kind of like this question. What is the z-score of 31.04? What is the z-score of 31.04? So you have to say, how many standard deviations is this above the mean? And you start marking it, and there's the answer. Didn't put the 9. Oh, there's 99%. That is a z-score of 1. And then you need to do the outside, which is 32 total. We're just taking 100 minus 68 equals the remaining outside, because 100% of the curve is covered if you go across the arrows. And then you subtract out the middle to get the remaining 32%. Cut it in half to get 16% on either side. The answer here is going to be 16%. So the remaining area above is 16%. Describe the gas mileage of the worst 2.5% of cars. And so the worst 2.5% of cars get less than, and the bottom 2.5%, that's the wrong graphic. The worst 2.5% of cars are going to be down here, because outside of 95, let's use this drawing. Outside of 95% is 2.5%. So we go right here and we do the 2.5 and the 2.5. Now, make sure to do your trick and make sure that when you go across these numbers, they add up to 100%. So make sure they add up to 100%, and that means the worst 2.5 are down here, so they get below 12.38. And we did miss one. Didn't see it. What percent of autos should get between 31 and 37.26? So we go back here. 31 and 37.26 is going to be right in here. Lot of ways to get this. What you want to think about here is the following. If you've already drawn your picture, you can get this instantaneously. But we know 68 is the inner portion. We're going to subtract that out of the whole. As in, if we take this area right here, which is 95, and we subtract out the 68, so we're going to do 95 minus the inner 68, and it would leave this total. And since we only want this one over here, we only want this area right here, we're going to divide that by 2. So we're subtracting out this inner portion, which is 68, out of the total blue area, which is the 95, to leave the remaining kind of, it looks like a spaceship right there, or something like the outer edges of it. And then we are dividing that by 2 due to the symmetry of it to get the portion. And that'll leave us 13.5 right there. Double check the math, but 13.5. Once again, if you were there in class, huge thing we did today in class is we drew this out. And you could just go right here on the picture we drew. And with the picture we drew, you could just be like, boop, boop. There it is right there, because there's the answer, 13.5. It won't change. Empirical numbers don't change. So, Adeline, how are you doing? Are these making more sense? As long as we did everything right. And then we got one more to go, the mean weight of a yearly breeding cattle. But tell me if it's making sense. Hopefully people understand this. I want some feedback. Just throw it to me. Be like, I get it. I know it. Because these can be tough. I used to have trouble with these, as everyone did when they first learned it. And then you're like, oh, I get what's going on. I get what's happening. It's just about standardizing data. Okay, here we go. The weights, the mean weight, is not the right one. Awesome. Tell me if I grab the wrong one, because it looks like there's more yearling cattle or whatever. Here we go. Yep. This used to be the homework. Okay. So we need to figure out, this one's mean. Please tell me if you get it wrong. They don't want a negative on this one. They should accept either answer. When we figure out how many standard deviations something is above or below the mean, we can just look at its distance from the mean. So we need to mark the notation here. This is the mean, and this is the standard deviation. These are cow 1 and cow 2. And so we could go here and do 1,000, which is the observation for cow 1, minus the mean over the standard deviation to get the z-score. And so 1,000 minus, and then the mean, which is 1185, and the standard deviation of 80. And this is going to be a z-score of about, I should be able to figure out this one in my head. It's going to be, having a little fun with math in my head, 2.3125. Did I get that right? 2.3125. See if I got that right. 2 decimal places. We'll find out if I got it right. The steer that is more unusual is the one that's further away from the mean. So the 1,000-pound steer is more unusual. You could z-score that, and we did get it right. So here we go right here. Double check the math. We did get it right. The thing that usually throws people for a loop on this question is you don't enter in the negative, which is a little mean. They're just asking how many standard deviations is below the mean, and there's the answer right there, 2.31. Don't put the negative in. It gets mad at you and tells you you're wrong. I really think it shouldn't, but it does. I've had that problem many a times, but it just says how many standard deviations is below the mean, which incorporates. The standard deviation is up here in the formula, 1185 and 80. When written out, the equation up there, I'll highlight it, says the mean and standard deviation. So this is the mean, and this is the standard deviation. Mean and standard deviation respectively when you write the equation normally distributed, which stands for the shape of it. And then the quantity right here is like 100 is the mean, so 100 would go right there. And then you could do like 10, and that means you go up by 10 units each time for standard deviation right there. So the normal is the shape. That's what the capital N stands for. Yep, no worries. Good question. It's just practice. We're just here to practice. And then we go to a nice light blue. This is the mean, which goes to the center of the curve. And then the standard deviation is going to be the unit. Whoa, magic. The standard deviation is going to be the units by which you go up and down. That's got it. Adeline, good work. I bet you're pretty much almost done with the quiz. So really good work. It's not that bad, right? Not that bad. Everyone hates chapter 5. They're like, this is so tough. And I'm like, it's just new. It's just new. Everything new is a little challenging. You go pick up a 5-pound heavier weight. When I picked up the 30-pound weights, when I picked up them, I was like, this is stupid. And then I did like a shoulder press, and I was like, this is really dumb. It's over my head now. Now I pick up the 20-pound weights, and I'm like, that's easy. Colin, Magic Kingdom 1,000 points. Back there doing some coding. You got it. Nothing in life is worth it if you don't work for it. Like everything that's given to you. I mean, it's great to have things given to you. Great. I would love it. You give me $1 million, I'd be happy. Don't give me $1 million. I mean, even when you're my student, don't give me $1 million. But when you feel that success, like just personal story here as we end office hours, like now when I pick up the 20-pound weights, like last night I was feeling a little fatigue in my like arm and elbow. And so I went and did some of my last exercises with 20-pound weights, which I had been working with like 2-3 months ago, which I'd struggle with. And I was doing like shoulder presses with 20-pound weights. You can critique my form if you want. But I was like, this is easy. And like 3 months ago, I was picking up that 20-pound weight. And I was like, oh God. Like you feel it. And so, you're going to, if it's painful, if it's tough, then you're doing the right thing. But just ask. You got personal trainers here. Take the personal trainers. We got the help. Colin knows right there. Colin is here. Bring us some pixie dust from Disney. Amazing, good positivity and everything. Magic Kingdom lost power today, causing all the rides to go down. Too bad that we didn't have. Oh God, I can't even read it fully. Colin, I'm so sorry. I'm sorry. I think it's time for me to be Thanos away, Colin. I got a protein bar for lunch. I need more food. Mewbot, let's end the stream. Colin, good seeing you. Darius, good seeing you. Adeline, good seeing you. Stay strong, work hard. Swing office hours. Bye.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!